Welcome to the VG tutorials. In this video, you're going to learn how to subdivide volume data into individual volume objects. The sample I'll be working with is the scan of an egg box that contains 6 surprise eggs. Since they've been scanned together, VGSTUDIO MAX considers all 6 eggs a single volume object. However, to perform analysis or measurement tasks, I will have to separate the eggs into individual volume objects. The split volume function allows me to do that, and much more, with a few clicks and in no time. So, in the next few minutes, I am going to show you how to split volumes using the split volume function. How to use split volume in an automated scenario. And finally, how you can apply split volume to any kind of data set to reduce the size of your projects. Okay then, let's get started. In the scene tree, I'll select the volume. Then, on the Volume tab, I'll select Split Volume. Let's move the dialog a little bit to the left so we can have a nice look at the 3D window. Usually, the preview I'll get from the default settings already looks very good, and I don't have to do any adjustments. But in this case here, one of the 6 eggs has not been recognized. Before I fix this, let's have a quick look at how the boundaries of the object will be determined. Since the volume object has a surface determination, the software automatically suggests using the determined surface for splitting the volume object. But a surface determination is not strictly necessary. If you haven't performed any, VGSTUDIO MAX will calculate the ISO value automatically to determine the material boundaries. Now, in some cases, the segmentation the split volume function offers may not work. For example, if the scanned objects are too close together. If that's the case, you can use the segmentation tools and the split ROI function, available on the Select tab of VGSTUDIO MAX. Now, in the case of the 6 eggs, the splitting worked, but there is one egg that has not been recognized. No worries, I can correct that in the filtering section. I can remove all components that deviate by a certain percentage from the reference volume, that is, the volume of the largest component. This option is suitable if the parts in the scan have approximately the same size. See, if I adjust the percentage here, the missing egg will be included in the preview. Alternatively, if I know the exact number of parts included in the scan, I can enter the number in this field here. And voila, here are the 6 eggs. Let's take a quick look at the Split Options section. By default, the volume objects will be sorted according to their position in the scene coordinate system. See? And the resulting volume objects will be dilated by 6 voxels. That means that there will be some surrounding air around the volume objects. This surrounding air is necessary to ensure reliable results for the surface determination or certain analysis. Actually, you can easily go for a dilation of 6 to 10 voxels. And don't worry, even if you raised it to a larger value. To make sure the component will not include voxels of another component, other components will be excluded during dilation. I would just not recommend that you reduce the value to less than 6 voxels. Okay, let's move on to the Name Template section. The Name Template section allows me to use the scanned object's metadata for the naming of the separated volume objects. Metadata, such as the serial number or cavity number, is often written in the object properties. For example, if your scanner uses the VG Project SDK interface. But no worries if that's not the case. You can import the metadata from a CSV file. Or you can obtain the metadata via an OCR analysis. Check out our video tutorials on OCR analysis to learn more. Okay, back to our topic, let's think of a nice name template for our surprise eggs here. First of all, I will substitute ROI part with egg. Of the metadata information, I want to include the serial number. So, I will add SN for serial number. And then I will add the corresponding placeholder. The table below provides me with a preview of how the names will look like. And if there's something I still want to change, I can do that right in the table. For example, if I preferred to label the new objects A, B, C, and so on, I could do that here. But actually, I don't. and I will leave the name as is. The naming is done. Now, what can I do with my split objects? Down here in the Output Options section, I can decide if I want to keep the original volume object in the scene. And I can create a VGL project for each individual volume object, which is especially useful in an automated scenario. In this case, I recommend that you check the Use Default Volume Name option. This way, all the volume objects in the individual projects will always have the same name, that is, Volume 1, in the scene tree, which will ensure that the macros you record will run stable on your datasets. I guess these two options do not require any further explanation. There is a third option, but I will come back to that one later. So for now, I'm done here. I'll click OK. Specify a directory for the resulting files. And let the software do the rest. And look here. With just a few clicks and in no time, I separated the 6 eggs that were scanned together in an egg box into 6 individual volume objects. Since the original volume object had a surface determination, the individual volume objects have 1, 2. And the individual VGL projects have been saved in the specified directory. Okay, now let's see how you can use the split volume function in an automated scenario. In the following example, I will use split volume to detect missing parts. To do so, I will record a macro with my original dataset, the egg box with the 6 eggs, that I will then run on the scan of an egg box containing only 5 eggs. I'll press F8 to start the recording of the macro. Then I'll select the volume in the scene tree and open the Split Volume dialog. Now, in an automated scenario, for the filtering of the components, we will work with the reference volume size. And one tip. If the macro you record will be used for parts that will always have the same size, I recommend that you deactivate Automatic and work with a fixed reference volume size instead to obtain an even more stable setup. On the other hand, leave this option activated if you want to run the macro on parts whose size will differ from the ones in the dataset you recorded the macro with, to allow for a dynamical determination of the reference volume size. In my example here, I want to run the macro on another egg box with eggs of the same size, so I will deactivate the Automatic option. Next, let's focus on the Split Options section here. I already mentioned that the components will be sorted by their position in the scene coordinate system. Now, when I record a macro, a new option will show up that allows me to check if the positions of the individual volume objects in the datasets the macro will run on correspond with the ones in this dataset. Let's make sure this option is activated, and see what happens if I run this macro on my scan of the egg box with the 5 eggs. I'll finish up the macro by running the calculation, and pressing F8 again to stop the recording. And with a macro recorded, I will now run it on the scan with the 5 eggs. And look here. I get a warning that egg number 5 is missing. I can also see this warning in the log section of the automation tool. And, as you can see here very nicely in the scene tree, based on their position, the volume objects' names are maintained. Now tell me, did I promise too much? Split volume will definitely help you improve your automated workflows. Finally, to round this tutorial up, let's see how you can use split volume to reduce the size of your projects. Actually, this is a really nice feature that you can use not only for multi-part scans, but for any scan that is just too large to handle. Let's open our initial project with the 6 eggs again. Now, before I proceed, let's take a look at the size of the volume data. More than 3 GB, a pretty large file. No news for any of you, I guess. But let me show you how VGSTUDIO Max can help you out. Back in the software, I'll open the Split Volume dialog. In the Output Options section, I'll check the option, Create Size Optimized Volume Data for each component. Now what VGSTUDIO Max will do is create new volume data for the volume objects. and the new volume data will only have a fraction of the size of the original one. Now you might think, oh my gosh, what if I lose critical data, or the quality of my data? Don't worry, this won't happen. What VGSTUDIO MAX does is remove some of the error that surrounds the object. Not all of it, remember. We need several voxels of error around the objects to get stable results for operations like the advanced surface determination and some analysis. But all the other surrounding error will disappear, which will reduce the size of our data set considerably. Let's click OK and specify a file name. Once the calculation has been run, let's see what happened to the size of my project. And look here. I reduced the size of my volume data from more than 3 GB to 740 MB. And that's it. The split volume function in VGSTUDIO MAX allows you to split multi-part scans with a few clicks and in no time. Using metadata for the naming of your volume objects has never been easier. Using split volume in your VGinline scenario or for batch processing is easily done and will definitely optimize your workflows. And finally, you can use split volume to reduce the size of your projects. I hope you enjoyed this video. You'll find a list of all our tutorials on our documentation landing page via Help, Show Tutorials. Plus, make sure to register on Nexus and make it your go-to place for sharpening your expertise. Get access to this video and other information material to get the best out of our software. And visit the VG community to exchange ideas, ask questions, and discuss topics with other users and our Hexagon experts. And stay up to date on the latest news and developments. Register now, a world of insight awaits. Thanks for watching, and see you soon on Nexus.